All right. Going to talk about functions today. Okay. First of all, a function is a rule that establishes a relationship between two numbers Okay, a function is a rule that establishes a relationship between two numbers that are called the input and the output. Okay, we've discussed this really twice last year in the 7th grade. We had it in one book and then in the algebra book as well. So, having said that, let's look at if we were to draw this box, okay, and there is a certain rule that applies to that box. When I put in a certain number, that number comes out a different way. For example, if I was to put in 4 here and I came out with 8, okay, we would call this the input, and of course this is the output. Okay, now if I just did that, there's quite a few different things it could be. Okay. In other words, what am I doing to 4 to make it 8? What's one thing I could be doing? Michael? Multiplying it by 2. Okay, that could be one rule. Owen? What's something else I could be doing? Do what? Plus 5 minus 1. So in other words, adding 4 to it. Yes, plus 5 minus 1. Larry? Larry? Larry. Okay, well, obviously there's an infinite number of things that we could do to it. Okay, you could add it, you could multiply it. Realistically, you could actually subtract it. Okay, if I subtracted by -4, okay, that would be the same thing. So there's an infinite number of things I'm doing to it. So realistically, to figure out what I'm really doing, I would really need to know another input and another output. So let's say I gave you this input. I gave you 6. Make it a different color. Make it 6. And then the output is 12. Whoa. Whoa. Okay, so does that clear it up more so than before? Yeah, it pretty much tells us what? We're multiplying by 2, okay? Because I can't add 4 to 6 and get 12, okay? Now, one other thing you could be doing is you could be taking the number that you input and adding itself to it and get the output. In other words, 4 plus 4, 6 plus 6. But the problem with that is that's not a function, okay? Because the function says that this relationship stays the same. Okay, so whatever I do to one input, I do to the other inputs. Okay, and so that's the difference in a function as opposed to just a rule that I've come up with. Okay? So the pattern must hold throughout the inputs. Okay? So if I get 10, if I come in here and I say, okay, I'm going to input 10 in here, then that's going to output 20, 20. Okay? So the rule would be this. Here's how we'd list the rule. Does anybody remember what form we put it in? Matt, do you remember? Yes, but it's reversed. Y equal 2x, yeah. You always list the function as y equal something. And this something is the rule, okay, or the thing that you're doing to the inputs. Okay, so in this case, it would be y equal 2x. Okay, now, most of the time that you deal with functions, okay, you're going to have a x and a y. If you don't, let's say they gave you the input, or they give you the letters or A and B, okay, the input is always the first letter in the alphabetical order. The second letter, the output, is always the second letter in the alphabetical order. So if I had M and N, then M would represent the inputs, N would represent the outputs. Okay? Now, that moves us to our other part. Inputs are also called domain. Okay? Input values are also called the domain. The output values are called the range. Okay? Now, the other thing that we have discussed that should be somewhat review is this. The what? Yeah. Okay. This is our input-output table. Okay? It can be listed vertically as the one I've done, or it could be done horizontally. Doesn't matter. Okay? Either way, you're going to have the same thing. So if we did one horizontally, it would look like that. Okay, and then obviously your X and your Y, your X would be there, your Y would be there. Draw a line down the middle. Okay, there's your input-output table. Okay, so when we're talking about functions, you have inputs, you have outputs. The inputs we call domains, the output we call range. Okay, and then you have an input-output table. Okay. The other thing that we can do with this is we can create one of two things. The 7th grade book talked about doing input-output tables that are sort of like a scatter plot, okay? But the main thing that we're going to talk about this year in algebra is graphing the function, okay? We're going to talk about graphing the function. Okay, when we talk about graphing the function, you're basically just saying, okay, for example, in our example up here, I had 4, 6, 10 were my inputs. Okay, let's say this. Let me switch over to our graph paper. Oh, that's too small. There we go. All right, so let's say I had my inputs up there. That's right, I don't have to do that. I got my little drawing over here. There it is. So much better than having to try to draw it straight. All right, so I got 0, 2, 4, 6, 8, 10, 12. Okay? These would be our inputs. Okay? Then let's see, I started with 4, right? Yeah. Over here, I'm going to go 0, 2, 4, 6, 8, 10. Okay? Well, our first input was a 4. Our first output was an 8. So I go here to 4, and I go up to 8. Okay? My next input was a 6. So it's here, and I go up to 12, so 12 is going to be right there. Okay? Obviously, I should have used some other values down here. Okay? So obviously, I didn't use the right values. I probably should have started with, 2, 4, 6, 8, do it that way. 2, 4, 6, 8, and you're still going to run into some issues because my graph's too small. Okay? But you can see the basic tier. So if I was to do 2, it would be there. So there's your basic graph of that function. Okay, the function of y equal 2x. Okay, that's how you would graph, that's how you would graph that particular function that we did. Okay, you list your inputs. Usually the input is down here where the x is, and the output is usually where the y is. Okay, if we remember our graph, you have x-axis, y-axis. Okay? Brandon, you have a question, or are you just trying to get more comfortable than you already are? All right. Get any more laid out there, we're going to have to get you a recliner. Was that Mr. Shelton? Uh-huh. Yeah, that's not a scatter plot. That's a graph of the equation. Good try, though. Good try for smarting off. And let's see, I maybe need to send this link to your parents, right? So they can. Well, I haven't seen your dad in a long time. He's still okay? Good. All right. Now, I want to look at a couple of problems in the book. So make sure you have your book out and turn to page 49. Page 49. If you look up at the top of page 49 at number 4, they want you to tell them whether or not that input-output table is a function. So let's talk about that. Okay? Anybody remember how we can tell whether something is a true function or not? Brandon.
If they're all using the same number to get there, like 2 plus 1.
Yeah, I understand what you're saying, but that is correct. But how do we tell, without having to know the rule, how do we tell on an input-output table whether something is a true function? You are correct in what you said, but how do we know by just looking at the table? In other words, if I can't figure out what the pattern or the rule is, how can I look at an input-output table and decide whether or not it's a true function? Caleb.
If the numbers on the right side are all different?
Number on the right side, so you're saying all the outputs are different?
If all the inputs are different.
Yeah, you're hitting around it. Yes, that is true. What do you think, Owen? See if we can get in the right words I'm looking for.
If the inputs are different and two or more of the outputs are the same number, but there are other ones that aren't.
All right. Well, y'all are getting more and more complicated. It's sort of simple. Zach?
Like on 12, if there's 2 inputs and they both have different outputs, then it's not.
Okay. That's what I'm looking for, okay? If there are 2 inputs that are the same, okay, but their output numbers are the same. In other words, if I plugged into my box up here at the top of the notes, if I plugged into this box, well, let me show you right here on this graph. If I had on this graph, if I said that one time 4 gave me 8, but the next time I plugged it in, 4 gave me 2. Okay? That couldn't happen, and it'd be a function. Now, it could happen, but it's not a function if it does happen. Okay? So, the rule is this. For something to be a function must have exactly one output for each input. Okay? Now, that is to say, for example, let's say I had this. Let's say I had these outputs, 1, 2, 3, 4, and 5. Okay? And that's the inputs. Okay? This is the inputs. And let's say my output was 1, 1, 1, 1, 1. Okay? This is a function. Okay? This is a function simply because, is any of our inputs listed more than once? No. So, I have to assume that if another 1 comes up, it's still going to be 1. Anybody tell me what that function is? Matt Shelton. Nope. Anybody tell me what that function is? Owen. Nope. Caleb.
Y equals X over 1.
Nope. Owen, let me go back to you. What is 4 to the first power? 4. So that's not right, but you're on the right track. You're on the right track as far as the y equal x to the something power. There you go. Y equal x to the 0 power. That's what this function is. Y equal x to the 0 power. Because anything raised to the 0 power is 1. Okay, now, would you ever see that? Probably not. Okay? But it defines what our function is. The inputs can have all the same outputs. Okay? Like this could be all zeros. Well, that means I have 0 over x. Okay? So you can have a function, all the inputs can have the same output. Okay? But if I plug a 1 in here, if I plug a 1 into this table and all of a sudden I come out with a 2, then that can't be a function. Okay? So what you're looking for when you're looking at an input-output table to see if something is a function or not, you're simply looking at all the input values. If all the input values are different, then you have to assume it's a function. Okay? Because you don't know if the function, stays the same over the same inputs. Okay? So, that's how we tell that. So I want you to do 4, 5, and 6 right quick. Do 4, 5, and 6. Look at them. Tell me whether or not they are a function. And if it's not a function, I want you to explain why. Okay, so problems 4, 5, and 6. Quickly write y in, and if it's an n, tell me why it's an n. I need to get my Jeopardy music again.